Good afternoon and welcome to the Designing and Building Pedestrian Infrastructure webinar with Darren Wilson and our guest speaker today, Danny Lynch from Townsville City Council. I'm Kelly Stewart. I'm the Marketing Manager at Wagners CFT, and I'm here with Business Development Lead, Darren Wilson, and Program Director of Townsville City Council, Danny Lynch, who will be presenting the webinar today. Just a few housekeeping pieces before we get started today. We are recording today's event and plan on making the recording available to people who are unable to attend via our YouTube channel. We're going to run through Darren and Danny's presentations first and hold any questions until the end. You'll see at the top of your screen, there's a chat tab where you can submit a question anytime during the webinar, and I will compile those questions for discussion at the end of Danny and Darren's presentations. Also, I'd like to flag that at the end of the webinar, we'll be circulating a feedback form. It's really quick to complete, and the information that you provide on that form will help us improve our webinar series to you. So, without further ado, I'd like to introduce Wagners CFT Business Development Lead, Darren Wilson.
Thank you, Kelly, and welcome to all our guests today for the Pedestrian and Boardwalk Infrastructure and Structures webinar series. I will just share my screen. Kelly, just confirming you can see that.
Sure can.
Great. So just a brief snapshot of my time within Wagners CFT. So we do like to promote internally from within. So I started off as an area supervisor in the pultrusion manufacturing division within this business and have evolved and gone through several roles within the company to be where I currently am. I've been with the business for 10 years and currently obviously business development lead for Wagners CFT. So we'll get started. So what are our key customer needs? We'll be focusing today on access and mobility, smart and efficient installation, sustainability, including environmental and total cost of ownership, cost budget constraints, Australian manufactured product in FRP, the design for Australian codes and conditions associated with those products, clear span structures for waterways, and our customer service. Access and mobility. The two structures that you see on the right-hand side are a result of considering, as we know, or as we found out, we have 4.4 million Australians that live with some kind of disability currently. And a huge consideration in early stage and discovery phase when we're talking to clients is to consider what is it we need to put into a design for this project, not just specifically focusing on what we can build out of FRP. So a huge consideration to meet Australian standards under 1657 code is to comply with those requirements, but also understand that whilst LGAs are investing and developers a lot of money in these assets, all walks of life and all people from the community need to be able to access easily the infrastructure and the facilities easily. A part of the Wagners CFT installation is to ensure that whilst we know our FRP is at least 50% lighter than traditional material, we're also considering site constraints which can lead to installing boardwalk structures from, as you can see in the left-hand photo there, where we've built a boardwalk that is utilising existing timber piles, but further down that boardwalk, as we'll get into a little bit later, we've actually installed new piles continuing on with the boardwalk to extend the length of this structure. On the right-hand side, that's another Wagners CFT boardwalk delivered in North Queensland that is utilising existing cleats and existing footings, but replacing what was an existing timber boardwalk structure. We do promote modular in design. We do prefabricate off-site as a part of our service, and obviously that helps to reduce excavation for footing requirements on site. Sustainability and environmental aspects. So the 100-year design life comes into play with what we call total cost of ownership. And we know through accelerated testing and a lot of internal destructive testing as well with comparing traditional materials to the Wagners FRP, that the 100-year design life has been factored into real-time testing and accelerated testing. So the Wagners CFT FRP structural material, we know will last 3 times longer than that of traditional materials. So what that basically says is that the asset owners and asset managers for structures that they're responsible for maintaining, short-term, medium-term and long-term, are actually going to benefit from the significant reduction in ongoing maintenance costs. We know that our FRP made by Wagners CFT is non-leaching, so it does not release harmful substances into the environment and suitable for all areas of conservation value and marine environments. It's inert, so it will not react to chemically prone areas and surroundings, and it will not react to moisture, chemicals and UV radiation. Sustainable and environmental continue. One of the considerations also in early stages discovery and in moving forward to 30% design phase through to ISC if issued for construction drawings, is when we're considering remote locations like a boardwalk that might be on a remote island or somewhere where machinery is a bit difficult to get into, we're usually working with a driven pole methodology for our structures. That allows us to not only minimise the impact to the environment, but it also allows for a fast, timely turnaround for installation on site. We know that that also helps to reduce the carbon footprint, and obviously Wagners CFT has an EPD, which is currently being independently verified. So this slide here, we touched on total cost of ownership a little bit earlier. The 2 photographs are clear examples of, we talk about 75-year to 100-year design life, and the ongoing maintenance costs will be saved significantly. So you're not having to replace a full structure. And by the time it gets to the 40-year to first site main maintenance inspection, we know that it will potentially, depending on the exposure to the sea spray in a coastal environment, only require a recoat of the UV protected coating. The compression and the connection capacity of all the CFT certified structures will maintain their structural integrity, carrying the same nominated, engineered and certified serviceability load limits as when they were originally installed. We give a 25-year to first maintenance on coated elements exposed to direct sunlight. And we also, as I mentioned, a 40-year to first site main maintenance and engineering inspection. Wagners CFT FRP products. We make the product in Queensland. We have our manufacturing facility in Queensland. So at the moment, we know we can help significantly reduce lead times due to the internal capacity that we have to ramp up. We're currently running at approximately 24/5 with the capacity to ramp up to 24/7 if required to meet deadlines and practical completion dates for clients. We can significantly reduce ongoing maintenance requirements by obviously talking about total cost of ownership and understanding the asset maintenance or owner's requirements from an on-site maintenance ongoing budget constraints. Our products and services are modular and lightweight and can be prefabricated off-site, whilst knowing that we can prefabricate pedestrian bridges in-house and deliver them to site fully prefabricated. And again, longevity of structures. So the Wagners CFT FRP materials made here in Queensland, Australia, are giving you that 100-year design life, peace of mind. What else we do? We do a lot other than just pedestrian and boardwalk. So focusing on that in the theme of this webinar, we'll just touch base on what else we do briefly. So light poles, which can complement pedestrian infrastructure and pedestrian bridges, we can actually incorporate that into our substructure to make sure that it's also highlighting an element of non-corrosive material as opposed to steel. Viewing platforms can be built off the side of the boardwalk, so landing areas and resting points. Engineering support and design. So we have a large amount of internal structural engineering FRP support with Wagners CFT. What we've done in the past 5 to 6 years is we've actually released our design guide. So that allows complete transparency for all external engineering consultancy firms to actually draw on that data and information. And we work closely with you whilst you design your project and engineer that structure. We're very confident in all of the information that we've got, and it's constantly being updated and evolving as we continue to develop new profiles with the business. Our installation support. So whilst we offer a full plug and play solution at Wagners CFT, what we can also do is rein that back in, and we can actually, if you want us to actually decide or supply, just the materials to your design that's certified by you, or we can do a design and supply and go all the way through to a installation support crew that can arrive on site to install the project for you. We incorporate multiple materials. So we're not just wanting to, obviously it's of benefit to the asset owner and the end client to make sure that they're considering total cost of ownership for reduced maintenance costs ongoing, but we're also considering aesthetics. So realising and recognising that different asset owners in different types of environments and situations may have a requirement for timber type materials to be used, but what we see is that in that type of situation, the CFT Wagners FRP material offers significant advantages to replace timber in the substructure. So piles in a boardwalk, for example, so piles, bearers and joists, and we can nominate a timber deck or a look-like timber type of deck material and design to carry that serviceability load limit that you require. Design for Australian codes and conditions. We're complying with all the AS standards, considering occupational health and safety requirements, the environment ISO 14001, quality ISO 9001 accredited, the environmental product declaration, the AS 1657 design and access and mobility code. We also comply with the AS 2156 walking tracks infrastructure design standard, along with the AS 1170 structural design actions. We have a full in-house research and development team that is continuing to grow. So we essentially, what we do is before we get an external test carried out to get the accreditation, we want to make sure that the product is meeting our own internal expectations through that R&D phase, basically with internal engineering, with developing new profiles. We do a lot of destructive tests, from 4-point bend tests, to 3-point bend tests to full tip load tests. So to suit a project that you may have, essentially we're able to provide you with that in-house testing capabilities to ensure that that gives you peace of mind and get that external accreditation for you to give you that confidence. We have an in-house quality assurance team. So we do a significant amount of testing as a part of our manufacturing of the pultrusion that we make for our structures. And a part of that inline testing is also carrying out a every 4-hour mechanical bend test, which includes a mass per meter weight. So every single mass per meter of product coming off of our pultrusion machines will actually contain the same context of glass and the same percentage of resin. And just touching on that, one of the unique facts about our Wagners FRP is that we actually have a 76% glass content, and the remaining being our vinyl ester resin. And then we get our UV coating on top, and that is one of the unique differences of the Wagners CFT FRP product. Clear span structures for waterways. So predominantly, like looking at systems in Australia, we're looking to prevent impeding objects, footings, or debris coming down through the waterways, essentially preventing blockages. So we want to be able to protect the structure from being inundated by debris causing damage. But if that's not able to be done, we can also maintain the strength through deflection criteria in the design phase to maintain those water velocities that may impact the structure. We have the reduced need for rehabilitation or repair following significant weather events due to the total cost of ownership and that 100-year design life again. Reduced environmental impact, so we're looking to reduce the surroundings, the natural habitat, and essentially the wildlife in the area as much as possible. And we minimise the use of piers or intermediate supports where required. That photograph there, and we'll lead into that a little bit later, is a pedestrian bridge that we delivered over in Canada, made here and prefabricated here as a spliced single span pedestrian bridge. It's approximately 29.5 metres single span, and it was designed and engineered by Wagners CFT and delivered over to Canada and then installed on site. Customer service and follow-up care, another significant part of what we're proud of. So we have well over 150 staff here at Wagners CFT, ranging from in-house designers, draftsmen, engineering, structural engineers, civil engineers, project engineers, plant and equipment engineers. We have a full, as I mentioned earlier, an R&D team with full equipment and facilities in-house. We also have a significant upskilled, experienced staff out on the floor, and they're responsible for making sure that all the QA is getting done in line with that testing that I was mentioning earlier. We are welcoming clients and anybody, in fact, to come through our manufacturing facility. And as you can see in the photograph there, that's actually a contractor that we work with. We work with a lot of contractors, a lot of external engineering consultancy firms, but LGAs and everybody basically is invited into our facility for complete transparency on how the product's actually made in Queensland. And we're very proud to be an Australian manufacturer of the FRP. I wanted to touch on a couple of projects. Top left-hand corner there is our bicentennial boardwalk. Actually, both photographs are our bicentennial boardwalk stage 1, which is for the end client with Sunday Regional Council. One of the constraints around this was deciding from what was an original timber structure, do we start with new footings? Do we try and reutilise the existing footings? What does that look like? So we work closely with the preferred contractor or awarded contractor to sort of do some load testing in this example here that you see in the photograph. And what has happened here is that we've saved significant monies for the end client and actually reduced the monies that was originally nominated for this structure to be built in the design, supply and installation process. There is another 2 stages to come, so we are following on from stage 1 through to stage 3 moving forward. We have sort of colour-coded the project to make it blend into the natural environment again, considering aesthetics. And that product there, as you can see in the detail, as well as the bottom photograph on the left, utilises a composite fibre mini mesh product with about a 13mm aperture in the material. We're always considering DDA compliance again and mobility access. So that was a considered factor in this example, and has been very successfully or very positively received by the community and local engagement. This project here, this was for Logan City Council. We call this the Compton Road Pedestrian Bridge, delivered last year. And this superstructure is a 31.9 metre single span superstructure. And this project was fully prefabricated in our Wagners CFT facility based in Toowoomba, Wellcamp, Queensland. Again, 100% Australian made FRP, structural FRP. And just a key couple of takeaways here is that the cords on the bridge are all one section. So there's no spliced connections in those cords of that structure. And they are actually the technology that we use for most of our structures, unless the spans are needing to come back in under a 10-metre single span type of arrangement. What we do is, and you can sort of define it in those photographs, is we actually bond the SHS material together to increase stiffness. Because with our modulus and our design guide calculations and FRP structure material, we're governed by deflection. So there's a lot of time that goes into designing and considering those deflection criteria. But to help us to reach those standards and requirements, we actually can quite easily meet the stiffness criteria by bonding our sections together. And what that essentially is doing is, if it was a steel structure, it's actually acting as if it was a weld line. And through shear or tensile testing, we've actually, over the years, discovered very confidently that the first thing to fail would be the FRP if under a significant load or impact, and it would be the deterioration or the cracking of the FRP, whereas the bond line was the last part of that process to fail under a full-scale destructive test situation. Pimpama Sports and Recreation Precinct. This was a photograph we highlighted earlier. Again, for City of Gold Coast Council, a huge consideration for a development here on this precinct is ongoing, so there's more stages to come. So the DDA compliant ramp with switchbacks there was the next phase, because above that, where the trees are at the moment, there's a pump track going in, and they wanted to ensure that not only was there full mobility access, but a full access for all parts of the community to actually use this facility safely and at all times. That project there, again, highlights a couple of our various profiles that we do. The footings in this structure were actually board pier type arrangements in the detail, not driven piles. And that's actually a circular hollow profile, which is our 154. And it uses, instead of using what we call a crush block in our bolted connections to increase connection capacity, we actually use crush tubes or bushes, for that of a better word. And what we've received in feedback from contractors is in the CHS profile, that's actually a huge time saver and increases the time frame from delivering a project like this on site. We spoke earlier about multiple choices of material being used in infrastructure projects. This is an example for a project that is in the Atherton Tablelands called the Lake Barine Boardwalk Access Ramp. The end client was Queensland Parks and Wildlife Services, QPWS, and it incorporated all of our Wagners FRP piles, bearers and joists. The piles were driven into the ground, and the technology was obviously incorporated into filtering through the decking, which is the mini mesh 13mm aperture decking product, but it also utilised the timber continuous rail on top and steel powder coated balustrade systems. So before this structure was actually implemented, one of the biggest challenges that parks had, and feedback they were constantly getting for a number of years, was actually that they really, people struggled, tourists struggled, and the community struggled to, if they had a disability or mobility issues, they couldn't actually access the nature trail that was a little bit further, and some of the viewing areas where you can actually get a first-hand picture and appreciate the lakes in that area from a tourism perspective. So now, as a part of this directly coming off the actual car park in this location, there's full accessibility for all people to enjoy the area up in far north Queensland. So at this point, what I'd like to do is I'd like to move into introducing our guest speaker, Danny Lynch, who was previous director for Townsville City Council. And Kelly, I'll just stop sharing and go to Danny, if that's okay.
Sure, absolutely. While you do that, I'll just let people know that we do have a couple of questions there. If anybody does want to add a question while Danny is giving his presentation, Darren and Danny will deal with those questions at the end of Danny's presentation. So keep them coming. I am recording them, and we look forward to answering those questions for you.
Kelly, that's up on the screen.
Sure is, Danny.
Okay, thank you. Okay, thanks everyone, and thanks Darren. Darren and I have become fairly good friends and worked together over the last 5 or 6 years, and certainly his comments of being available to go and have a look at their site at Wellcamp, I thoroughly recommend you do that because it's one of the things that really brought me to what we do today with these materials, because you know, we look for innovative solutions, and I can confirm that Wagners are well ahead of the game, and it's certainly worth the trip just to go and see how their infrastructure is built, and you know, to see the robots in action, and you know, where we'll be in 10 years will be something amazing. So thanks, Darren, for the introduction. As you can see, probably a recent project we've just finished is the boardwalk, which is the main photo in this presentation, but I'll touch with that a bit later on. But As Darren touched on, I was the Director for Infrastructure and Operations, and I was responsible for probably over $6 billion worth of assets. So being responsible for the asset department, certainly it was critical to develop innovative technology to maintain these assets. We needed to provide value for money for our community. So again, we just needed to start looking at different ways on how we do things at council. Sorry, I just didn't have my photo up there. Different ways that we do things at council and how we're going to maintain it. So every local government probably is struggling with budgets, and certainly their assets. Each year they tend to leave them longer and longer to maintain them, which ends up in one result, which is failure. So innovative solutions moving forward is certainly one thing that Townsville City Council is very proud of what we're doing going forward. So obviously for the ratepayer, we need to provide value for money in all our products and services that we deliver. So, the ratepayer are the ones that pay our wages and looks after the city. So we need to make sure that everything that we do is providing value for money. We also need to understand our asset life cycles and how we can influence this with new products and innovative solutions that come onto the market. So, I always say that one of my best friends is Google, because there's a lot of people out there that are doing things different from what I do. I just need to tap into that. And that was certainly one way I got into Wagners products and what they use. So for one of the biggest projects I've done recently was the Townsville Stadium. So it was a $300 million stadium built by the state government. Council was responsible for delivering all the associated infrastructure, which included roads, water, footpaths and bridges. So our portion to the project was probably around 30 million, but there's a lot of works involved. So the project included various bridge designs and footpaths. We went through waterways and mangroves that were surrounding the stadium. And as you can see in that picture there, being able to get different colours in the products that we use was able to blend into the environment. And the green there was fantastic product and finish that really blended in well with the trees. But not only were we using Wagners joists and newel posts and railings, but we also were using their pile system that was driven. So in the soil content there, it was so easy to just have their little excavator to be able to move through there instead of bringing big excavators that would damage the environment. So great product. It was very light for the workers and easy to install, but one of the things, it's very quick to install as well. So it was certainly a win-win, and the timeframes we had on the stadium, the finish that it provided, people still talk about it today. So there's probably 2.5 kilometres of footpaths and bridges and boardwalks associated with the Townsville Stadium. So as you can see, a lot of the works that we did was elevated, worked over water. So, your traditional timber posts, we'd sort of gone away from that because we did, about 10 or 12 years ago, we built a facility called Jazeen Barracks, and the whole Jazeen Barracks was, I think it's about 4.5 kilometres of walkways and, looking points, was built out of timber. And after 10 years, it's certainly the maintenance costs are increasing and are huge. But again, the timbers are starting to deteriorate rapidly and become safety issues. So with the products we've been using now, with the 100-year lifespan for the products from Wagners plus the modwood decking, we're looking at least 25 years for the decking and 100 years for the Wagners products that they supply. So it was a no-brainer on the stadium. It was excellent to be able to use their products. The ease of installation was another point, but certainly the speed that they were able to install this as well. So we were able to continue working around them with different machinery and things like that. So it's certainly a great product, and it certainly offers to blend in with the environment and to be able to look across the waterways and across the stadium. Magnificent structures that were built. So if you look at the stadium, it's probably Townsville's pride and joy. We use Wagners Composite Fibre Technology because it certainly was fit for purpose for the location and certainly maintenance free and value for money solution. So the ideal products, you can see the boardwalk that goes around where the cul-de-sac is. We also use concrete footpaths as well. So we split it up, but you can see the difficulty in trying to build in that sort of terrain with the piles and the structures. So certainly the lightweight products and certainly the availability was a big win for that stadium. So again, it is just so utilised now. It's the old story, you build it and they'll come. We do see so many walkers and runners and cyclists that utilise this just out of normal hours. So it's been a great benefit for council what we've done. So great materials and great finish. One of the other recent projects we did, I'm not sure if people know where Castle Hill is in Townsville, but there's a number of tracks up from the top end of the hill, but there was certainly access point from the bottom of Walker Street, but it was certainly a difficult access track to try and build to get access to the top of the hill. As you can see in this design, it was, there's a lot of rock pinning, a lot of works involved in just the geotechnical itself, but Wagners actually designed and construct this. We were partners in the design. But again, we've utilised the materials of the composite fibre materials and the reinforced polymer because this will give us a 100-year lifespan. And certainly in Townsville, if people know it, it's a very hot place in summer. We get a heavy wet season. So products that you install need to be able to withstand the elements. And certainly, one thing we do see in Townsville is the heat just destroys timber products unless they're maintained. But as you see, council's budget's very hard to maintain that sort of infrastructure. So this has been a great win for the ratepayers of Townsville, is to be able to access Castle Hill from another point of view. But again, we're proud to say that, this product will be there in 100 years' time. And it's certainly, again, another, kudos to Wagners for their product and their installation. So it also provides, a safe access and long-term solution for this area because it's certainly different terrain, and it was certainly an interesting project considering the rock pinning exercise we had to go through. So. East End Boardwalk. So this was the last project I was involved in. So, it's the priority development area in council. So it's been identified as, council needs to look after the pedestrian access. So one of the things we looked at is the pedestrian access from the stadium back into Palmer Street, our nightlife precinct in Flinders Street East, but Palmer Street where the restaurants and all the action happens. So we've been able to actually get so many more people back into the CBD by the PDA development area. So one of the projects, stage one, is the East End Boardwalk. It was a 280 metre by 5 metre boardwalk along the Ross Creek. And that photo there shows you the trusses that support the infrastructure, and then it's tied back to a beam on land. So all those products you can see there are Wagners, but we did do a micropile system because it was very difficult terrain. It was in rock. So we had to use micropiling, which was a huge exercise just on its own. But again, the lightweight materials and to be able to lift the decks and all the infrastructure in place, to be able to prefab it. There's a car park behind there, so we were able to do a lot of the prefab exercises. Then the crane was brought in to lift in place. So again, great lightweight system, maintenance free. And the one thing we look at is that marine environment. It's a very tidal area. I think it's about a 4 metre tide drop in that area. So again, infrastructure and materials that can handle the environment in Townsville were critical for this project. So Wagners did this project in a design and construct and worked with council's project management office to deliver. And certainly the fibre reinforced polymer materials suited the existing marine environment. So you can see that's about 75% of the boardwalk through there. So it's about 5 metres and curls around at the back of a business and goes through to where that car park was. We've also utilised Wagners technology for the light poles. So, you know, they've been fantastic, again, designed for an environment like Townsville. So, you know, we are in cyclonic conditions up there. So anything that we put in place in Townsville must be able to meet, you know, heavy Australian standards and certainly meet the criteria for a cyclone environment area. So again, magnificent wide boardwalk, 5 metres. We sort of utilised the biggest width we could. So it'll incorporate through the car park area. We'll be able to hold events through to the museum. And part of the project, stage 2, will be to build a bridge across the river from the Wagners installed boardwalk to Palmer Street, which will link up to the food precinct. But again, part of the design process for that bridge will be to utilise Wagners materials, so it matches in right across the bridge plus along the boardwalk here. And then there's another stage 3 which will go up Tomlin Street, which will be similar or identical to what we've done here. So the PDA was, you know, it's a 3-step process. We have to work out with our budgets and certainly government funding. So this received Works for Queensland funding. So 1/3 of it was paid by the government and 2/3 by council. So again, you know, these are some of the shots. You look at the lighting at night time, you know, the beautiful wide boardwalk and materials. You know, we've utilised stainless steel handrails again for lack of maintenance, and we've used the aluminium balustrading. But sort of all the materials, 100-year lifespan, and provide that maintenance-free period that most local governments are chasing. So you can see the full extent of the boardwalk on the left-hand side, and that was one of the openings we had for the V8. So you can see that car park at the bottom right corner that will eventually become a precinct area where we can hold entertainment and activities for the stadium. We were lucky enough to have the State of Origin a couple of years ago, so we closed that street and have events. But one of the big things will be to build a bridge across the river, which then will give access from Palmer Street, the stadium, to the events precinct in that car park, and also meeting disability compliance. So it's a long 3-step process, but stage 1's built. We're designing the bridge now across the river, which will be finished in December. So yeah, overall, probably for me, 3 fantastic projects that I've been involved. 2018, I met with Wagners. I was invited down to their Wellcamp facilities, and it just blew me away, the technology that they're using now and where they'll be in the future. So local governments need to be looking at innovative solutions like this to save money and budgets. And certainly, as Darren said, he will welcome you down there and take you through the factory. So that's about it for me. So thanks, Darren. I hope that's covered a lot of the projects that we've been looking at, and certainly we'll be looking at using their materials in the future.
Thanks, Danny. Thank you.
Wonderful. Thank you so much, Danny. I don't know whether I have any questions specifically for Danny, but I think given the time, 2:12, Danny does need to leave for another meeting at 2:15. So if anybody has a question specifically for Danny, if you'd like to pop it up into that chat now and we can answer that straight away. In the meantime, we might go to the first question that's come in from Stuart Small. Stuart wanted to know, for elevated pathways, are you able to utilise FRP materials for the pile foundations, and can such walkways support golf carts?
Yeah, so thank you, Stuart. A good question. And to answer your question, yes, we can utilise our WCFT structural FRP materials for the piles and abutment type arrangements in design. And as such, obviously, we can design to carry golf carts. And when we go back to Danny's project in Townsville, the East End Boardwalk, or the stadium project, in fact, I think that was a serviceability load limit. It had a 20 kilonewton point load applied to that structure. And it's all about just understanding the dynamics and deflection. So where, for example, pile and abutments are traditionally, either steel or concrete abutments and the bridge will be landed on top, we have actually very successfully, a number of times in the past, utilised all of our CFT FRP products in that abutment and footing detail.
So I can probably just add in there, Darren, that yeah, that was one of the stipulations for the stadium and for the East End Boardwalk, was for the golf carts. And I think even, it's worth looking at the Polaris police vehicle. Is probably one that has come into question now, especially with the amount of crime around. But that is something a lot of our boardwalks that we look at now, is the police have just asked us. The Polaris is the heaviest they'd use, or motorbikes. So I know that we definitely allowed for the golf carts for maintenance for our materials. So.
Excellent. Well, Danny, I don't have any questions that have come through for you there. So if you need to go, please feel free to leave, and we'll catch up with you afterwards. We'll move on to the question from Sahar. What was the total cost to complete the local City Council pedestrian bridge, the Logan City Council pedestrian bridge?
Thank you, Sahar, for the question. And okay, so it was delivered around 2 years ago, approximately. So if we go back there, considering it was a 31 metre superstructure single span project for us, that project would be in between, roughly coming just under $1 million, just over $1 million for design and supply. And considering there's a lot of mitigating factors there that can help to create design wins and meet budget restraints, and again provide cost savings. As far as the installation side of it goes, I probably won't comment too much on that, because we were sort of design and supply and certifier on that project. We weren't actually PC or principal contractor or lead contractor for Logan City Council. But happy to provide one thing that we do, a space we do heavily entrench ourselves in with prospects and early discovery phases with engineering consultants and asset owners, is budget estimates. So what we do with, basically a free of charge service within Wagners CFT is we can talk to you in early stages and again that discovery phase to understand high level scope, and we can, off previous projects, provide you with a breakdown and a line item with contingencies built into that until we get further information like geotech, survey, all that type of thing from site information. And then we may be able to most certainly give you a budget estimate that'll help you with your budgets and making sure you're on track for delivery of those works moving forward. So very happy to provide that service.
Yeah, I see Sahar has just added another qualifying question there. He just wanted to know that, presuming that was not including substructures. But if you like, we will circle back to Sahar and have a bit more question, have a few more, a bit more information ready for him when we circle back to you, Sahar. We'll move on to Brian Richardson's question, Compton Bridge. He just wanted to know, when bolting the pieces together, how do you stop the members deforming when the bolts are tightened?
Yes, thanks, Brian. Excellent question. So in the presentation, I briefly touched on the crush block, what we call crush block / insert. So in Wagners CFT, we have another area of the business at the same facility, which is our injection moulding area of the business. And we're manufacturing a crush block, essentially, that is inserted into our hollow sections. So for any bolted connection that you see on that Compton Road bridge, for example, the cords going to the webs, etc., every single bolt internally, where the bolt will go through and adjoin to another member, will have on both members a crush block internally, preventing concavity and crushing and increasing compression and connection capacity. And we're very happy to share that detail also. And that can be found in our design guide and product guides.
Great. That design guide and product guide too, Darren, I'm going to send out to everybody who's attended today's webinar in an email this afternoon. So you'll have all of that in your email box by this afternoon. Darren Stevens just wanted to ask as well, how are Wagners structures affected by fire, mainly vandalism?
So, Darren, thank you for your question. Good name. And I just want to add, so basically from a fire resistance capability point of view, a key part of protecting FRP or structural FRP is around the coating and the resilience and resistance protecting that product from fire. So for boardwalks, we know that in those bushfire type environments, they're going to be flash fires. So they're going to be fast, hot, sweeping fires that come through. Our coating is what we call a Vitraflon 795 coating. So we know that our FRP structures are rated to a BAL 40 fire resistant rating for that application. But if we move to vandalism, it's also an anti-graffiti type of product or coating that goes on the FRP. So if for whatever reason there is a graffiti that's put or a bit of spray paint or something, there's an easy way to remove that, whether it's a standardized solvent solution or whether it's just depending on what paint they've used to wipe that off, which does not affect the Vitraflon 759 coating that we use. On top of that, though, we have multiple coatings for our FRP structures. So, for example, power poles, we're now supplying power poles on top of our already, which started back in 2002, cross arms for electrical utilities. So those products in their self and in their own respective environment have another completely different R&D and engineered coating system applied to that product. So they have to meet higher standards. And we've in fact got photographs of the tragic New South Wales fires that swept through down south a few years ago now, where the timber pole has literally been decimated and vanished, nowhere to be seen, obviously, through those fires. But the Wagners CFT FRP crossarm was actually still completely intact, had some slight burn marks on the coating, but structurally still had the conductors and the power lines attached to the CFT Wagners crossarm, keeping it off the ground, which is ultimately keeping it very safe for the community.
Mm. Reece Schmith, he has left the chat now, but he's going to circle back and watch the recording, which I'm going to make available to everybody later this afternoon as well. He's just wanting to know damage sustained to infrastructure utilising Wagners CFT products, such as from a vehicle impact to a bridge. How do repairs differ from more traditional materials? And do we have any examples where there's been a scenario like that?
Yeah, so thanks, Reece, for the question. It's very much intermittent when we do receive feedback like this. What we do know is that from an impact resistance, we don't crumple and fail when you follow a graph under a controlled testing environment point of view. We tend to, obviously, we'll have a lower modulus than steel. So steel, whilst it'll maintain stiffness against an impact to a certain point, what'll happen with CFT from Wagners is that it'll bow from that same load or impact being applied as if it was the steel member. But once it reaches a certain load, steel will crumple and fail and crease, whereas FRP from Wagners CFT will actually continue to climb and maintain its structural integrity. And then at ultimate failure, it'll actually, it's the resin that will fail in the FRP. But again, touching on Wagners FRP having a 76% glass content, the composite glass content, which is one of the highest in the world for FRP structures, structural material, sorry, and the type of glass we use, of course. The form of the profile will actually maintain itself to a certain percentage, but dependent on the impact. We have actually recently, from an LGA, received a report where a car has actually impacted one of our structures. And it has travelled at some speed to actually impact the bridge. But when you look at the Wagners CFT bridge, and it's approximately a 18-metre long single span structure, with that significant impact, replacing the members compared to a steel welded bridge is going to be a lot cheaper and a lot easier. But what's incredible to note here is that the bridge is still able to be opened or kept open from a safety compliance point of view for the public. There has been obviously investigations and assessments carried out already to maintain that safe opening of that structure. But whilst we arrange the materials in the webs, which typically are needing to be replaced in this section, the structural strength of the cords in that pedestrian bridge are able to maintain the integrity of that project, or that bridge, sorry, to allow people to still continue to pass through. I hope that answers Reese's question.
Yeah, if not, we'll circle back and touch base with Reese as well. So we'll move on to Paul Whitaker's question. Paul wanted to know, how do your FRP products as finished components compare in dollar value against traditional structures in bridges and walkways?
Is that from Paul, was it, Kelly?
Yeah, Paul Whitaker. So just near the bottom there of the chat. Yep.
Thank you, Paul. So how do FRP products as finished products? Okay, so pre-COVID, we were seeing some changes in the balance between traditional steel materials in bridge components or bridge builds to CFT FRP. During COVID, we could also recognise not only the lead times, but the cost differences actually starting to come back in and even out. And post-COVID now, and a trend in the industry is that whilst a lot of these steel materials that are being fabricated here in Australia are coming from overseas, the price is something that they're unable to control a lot of the time. And being a manufacturer here in Australia, actually, in fact, the only FRP structural manufacturer of that material, we can control the virgin materials that go into the product, and we can maintain and hold our price a lot of the time. Of course, there's certain areas where we have to adjust to make sure we're covering those areas, which does increase slightly where required. But on par, we're actually quite competitive. We're actually very competitive right now to steel structures.
Great.
But just to touch on that again, sorry, to finish off on that, something to note there too is that whilst in some instances we will be considered a more expensive option, but not all the time, just so we're understanding that, it's important to recognise the total cost of ownership over the duration of the asset. So that involves obviously ongoing maintenance and what happens past that 40 and 50-year design life period.
All right. This is our last question. It's from Craig Johansson. With the bicentennial boardwalk, was consideration given to high seas and debris impact?
Thanks, Kelly. And thanks, Craig. I appreciate the question. So that project there is designed for cyclonic weather events. And again, from a dynamic point of view, that really helps the product to shine when there is a significant cyclone impacting the structure. And from a high seas and tidal impact point of view, a lot of our bridges, just sort of digressing a little bit there, but still on the same topic, water velocities, we're designing past 4.5 meters per second on some of our structures. So if it's unable to be raised above the RL or above that water height where it's likely to get impacted by those wave forces or tidal forces, we can actually, again, bond our beams or create or utilise some of our larger profiles to increase the stiffness and carry the dynamics of those debris or the impact that'll be coming in connection with the structure.
Great. All right. Well, I think that's all the questions that I've had come through today, Darren. Thanks so much to everybody who has popped some questions in there for us. I've just put into the chat our feedback form, and I'm just going to share my screen now for anybody who wants to access that feedback form for today's webinar via a QR code. You just scan that QR code and complete the feedback form. The information that you provide to us is hugely helpful for us to improve these webinar series that we're giving to you. Also, just wanted to flag that the next webinar is next Wednesday, the 30th of August, and that is on designing and building marine infrastructure with our guest speaker, John Leman from International Marine Consultants. We're going to leave you today with this video from Lake Barine. Hope you enjoy, and thanks so much for attending.